ठीक है, ट्राई करेंगे, नेक्स्ट क्लास में देखेंगे उसको। Now just read this definition, that in an ordered set, see, if X is any ordered set with, then, and A is an element of X, then we can define these four types of set called rays on any ordered set, denoted by this one. We will use the same symbol, that open interval A to plus infinity means for collection of all those X such that X succeeds A, and minus infinity A as a collection of all those X such that X precedes A, and here closed interval A to infinity as collection of all those X where X is greater, either precedes A, X either succeeds A or is equal to A, and here X either precedes A or is equal to A. So you can see that set of first two types are called open rays and sets of last two types are called closed rays. We will use this notation. So just like what we have seen in case of reals, because the real number is also an ordered set. So in the same way, but here this one is defined on an arbitrary set, this is rays. So the use of the term open suggests that open rays makes are open sets in the order topology, and so they are. Consider, for example, the rays open interval A to infinity. Actually, here it is explained that why this one is an open set in with respect to the order topology on X. So we know that the basis for order topology will be of this type if A naught B is the, if A naught is its least element, or this open interval AB, or say open at A and closed at B naught if it has the largest element. So basis members will be of this type. So if this is open, if this set is open with respect to order topology on X, then it must be generated by union of the basis members of this type. So to show that open interval A infinity, so that is what written here, that if X has the largest element B naught, then A to plus infinity equals the basis element A B naught. A B naught. If X has no largest element, then A to plus infinity equals the union of all basis element of this type, A to X. So that one is clear, where X precedes A. In either case, A, so in both cases, this is open. Why? Because basis members are always open and arbitrary union of open set is open. So using this, one can show that this type of rays are also open always with respect to order topology on any ordered set X. A simple argument is going to work for this one. So read it one word by word. The open rays in fact forms a sub-basis. So this one is important. Sub-basis for the order topology on X. Now recall the definition of sub-basis. Okay, I will come to this one. Actually, product topology. In that we will recall this sub-basis. So as we now show, because the open rays are open in the order topology, the topology they generate is contained in the order topology. On the other hand, every basis element for order topology equals a finite intersection of open rays. Actually, if we recall the definition of sub-basis, let me recall here the definition of sub-basis. So there is a property that sub-basis, their union should be equal to whole X. See, any collection script S, a sub-basis script S for a topology on X is a collection of subsets of X whose union equal to X. This is the first requirement, that collection, members of that collection, their union should be equal to whole X. And second, the topology generated by the sub-basis is defined as the collection script T of all unions of finite intersections. So if one is interested in generating a topology from a given collection, from a sub-basis, first of all, we need to take its finite intersection and then take arbitrary union. So that is going to the generate topology. So whenever sub-basis is given to us, remember it is it's the union of the members of sub-basis is going to equal to whole X, and to generate topology from the given sub-basis, we need to take its finite intersection and then take union. So we will come on this example later on. And remember that finite intersection, basically we will also see that the finite intersection of elements of S will be a basis. Whenever sub-basis is given, its finite intersection of members of this collection is going to be a member of the basis. So using this property here, so that is written here that the open race in fact forms a sub basis for the order topology on X. Sub basis means intersection of finite open rays is going to be the basis members of these types. So one can check that their intersection, their finite intersection will be either of this type, or this one. This is the and union of the rays. I mean, if X has no largest element, then A2 plus infinity equals the union of all basis elements of the form this. Now, here, yes, every basis element for the ordered topology equals a finite intersection of open rays. The interval AB, for example, suppose I want to see this interval AB can be expressed as intersection of minus infinity to B intersection A2 plus infinity. So you can, just for the sake of explanation, we can draw it on this minus infinity to say B and and A to infinity. Say if they intersect A2 plus infinity, then we have the intersection of this type. So you can say that this one is a member of subbasis, this one is a member of subbasis, but their finite intersection is a member of, is a basis element generating that topology. So here, since we are considering order topology, so you can see that the basis member of order topology will be of this type. So the finite intersection of the members of sub basis is always going to form the member of the basis. So this is what written here, that every basis element for the order topology equals a finite intersection of open rays. For example, the interval AB equals the intersection of this and this rays, while A naught B and A B naught, if they exist, are themselves open rays. Hence, the topology generated by the open rays contains the order topology. Now let me come on this product topology, then we will come back to this one. Now see, suppose X and Y are two non-empty set. X is equipped with some topology, say script T, and Y is equipped with some topology, say script T dash. Then how to define topology on their Cartesian product? So that topology basically we will refer here as product topology. So that topology, that is written there, that if X and Y are topological spaces, there is a standard way of defining a topology on the Cartesian product. We consider this topology now and study some of its properties. So the definition is that the product topology on X cross Y, here cross denotes Cartesian product of their sets X and Y, is the topology having as basis the collection B of all sets of the form U cross B, where U is open in X and B is open in Y. U is open in X means U is a member of the topology present on X. U is a member of the topology present on X, and B is a member of the topology present on Y. So here is the proof that the collection of all sets of this type is going to form a basis for X cross Y, for this Cartesian product. So to prove that it is a basis, you need to show that around each X belonging to X, let us denote ordered pair, XY belonging to this X cross Y, we always have at least one basis member of this type containing this point. And second, whenever B1, B2, two basis members of this type exist, then there must exist a B3 which is contained into their intersection B1 intersection B2. So this is written here. So you can see that, see, the first condition is trivial. Why? Because see, in suppose let me take this X and Y. Then obviously around each this X I can always construct an open set, because why? Because T is a topology on X. So suppose this topology generated by basis B, and this topology script T dash is generated by script B dash. Then since this is a topology on X and this one is a basis generating this topology, so using the definition of this basis, around this X, around this X I can always have at least one basis member containing this. And similarly, since script B dash is a topology generating script T dash, then for this always I have at least one basis member containing this. Say, let us denote that by say U1.
Excuse me, sir.
Yes.
Excuse me, sir.
हाँ बताएं.
Sir, some students are waiting outside.
Okay. So look at the proof. Why we have the first condition? Because see, on this we have the basis generating topology script T and B dash generating script T dash. So since this one is a basis, so using the definition that around each X, I mean around for this X containing this, I always have some U1, I mean some basis member from the script B, because it is going to generate the topology. It is also basis, and similarly I can always have some members containing y from the basis b dash. So their Cartesian product is going to contain this one. So always I have this type of elements. Now second condition is almost as easy, since the intersection of any two basis elements. See, suppose there is one basis element, say b1 is equal to u1 cross v1 containing this xy, and suppose there is another basis element, say b2 equal to u2 cross v2 containing this one. Then we know that their intersection u1 cross v1 intersection u2 cross v2, using set theory I can write this one as this one, u1 intersection u2 cross v1 intersection Cartesian product v1 intersection v2. Now you can see here that since u1 is a basis member of the script b of the basis b generating topology script t, and u2 is also a basis member from this B generating topology T. So intersection of open set, finite intersection of open set is open, and within this U1 intersection U2, since B is a basis, so whenever two such element exist, I am talking in this X, since U1 is a basis member, U2 is a basis member, so for all those X, U1 for all those open basis members U1 intersection U2 containing X, using the definition of basis B, I always have some B3, containing X and is contained into U1 intersection U2. Same I can do here. And if we take the Cartesian product, then that is going to be contained into U1 intersection U2 cross V1 intersection V2. So this proof is already written here. I have given hint, you can read. Now next is, suppose we know the topology. Next is how to, if topology on X and Y are given, and if topology generating if basis generating topology script T on X and basis generating topology script T dash on Y is given, then how to claim that what will be the topology on this Cartesian product X cross Y. So here definition is, so we have to follow this definition. According to this definition, script B is a basis for the topology of X, and suppose script C is a basis for the topology on Y, then collection of all Cartesian product of the basis members of script B and script C is going to generate the basis for the topology on Cartesian product of X and Y. So let us understand through geometrical. Suppose this one is X and this one is Y. So taking Cartesian product, we have this whole plane. Just for the pictorial representation here. Now suppose there is any set U1, any open set U1. We know that, see, in case of R cross R, let me take this one R x-axis and this one is y-axis. So in case of this one, we know that open intervals R is going to generate on R with standard topology. Collection of all open intervals is going to generate the basis for standard topology. So let me by this AB by U1, and similarly let me generate this CD, C to D by, say, C to D, let me call this one C to D by, say, V1. Then you can see that, see, this U1 means this one, this, and U2 means this one. So if you take their Cartesian product, this one, both ends are open. So in front of this, and let me draw here. Similarly, you can extend it here. So you can see that the Cartesian product will be this member, but these boundary points will not be included, because I have to take Cartesian of each X with all of the Y here, and thus this whole portion will be there. So what will happen that U1 cross U2, U1 Cartesian product V1 will be this. open rectangular region, and we know that open rectangular region u1 cross v1, open rectangular region of this type, say ab cross cd, is going to generate standard topology on R2. Standard, this will be basically basis member for standard topology on R2. Earlier I already have proved that topology generated by collection of all open circular regions or collection generated by collection of all open rectangular region, both are going to generate the same topology, standard topology on R2. So this is a basically picture depicting that one. Similarly, if suppose we have some u2 interval of this type, and here we have interval of this type, then again their Cartesian product will be denoted by this one. So this is the way to look at the basis. Another that is given here. So you can read this proof. Do it by yourself. I think there should be no doubt in this one. This one is just you have to use the basis that script B is going to form basis on X. I mean generating topology on X, and script B dash is going to generate topology T dash on Y. Use their definition. So you can always have U cross B containing this XY ordered pair XY, which is contained into this W. Whenever we consider W as open set. So first of all, read it by yourself. Then I will discuss that this collection is going to be a basis. If you have problem, then I will discuss, because due to shortage of time, I want to skip all this, because similar proof we have already done earlier. See, to prove that this is going to basis, you need to show that for every xy, in this book it is noted by this x cross y. So around each xy, I have basis elements of this type containing every x y belonging to x cross y. This is the first condition, and second is whenever there are two basis member of this type, say b1 b2 of cross b, here b1 represents b1 cross c, not to use the same notation. Suppose we have b1 cross c1 and b2 cross c2, as two basis members containing xy, then we need to show that there exists b3 cross Cartesian product c3, which is contained into their intersection, containing this point and contained into their intersection. So that is proved here, that is given here. So take it as home assignment and do it. If you have doubt, then I will discuss it again. So now example 1, you can see example 1. We have a standard topology on R, the order topology. Basically on R, we have seen that standard topology and order topology are same. The product of this topology with itself is called the standard topology on R2. Here we are taking Cartesian product of these two x and y, and on both we have a standard topology. If it has a basis, the collection of all products of open sets of R, but the theorem just proved tells us that the much smaller collection of the products AB cross CD of open intervals in R will also serve as basis for the topology of R2. So that already I have discussed that, because on this R, according to this result, if we know the basis of X, let it be given by script B at basis generating topology on Y given by script C, then their collection of all their Cartesian product of the members of the script B and script C, basis members of the script B and script C, is going to generate topology for X cross Y. So using that, it's here written that collection of all the members of the type AB cross CD is going to basically generate the topology of R2. Basically, this will denote your open rectangular region. Because whenever I draw this on XY axis, suppose we have this A and B and this one as C and D, so it is going to generate open rectangular region. Why? Because let me produce this one. So it is going to generate open rectangular region, and we know that collection of all open rectangular region, in earlier class I have already explained that collection of all open rectangular region is going to generate the standard topology on R2. So this is what written here. Now, it's easy to define. See, product topology, here this result is very important, that it is sometimes useful to express the product topology in terms of sub-basis. To do this, we first define certain functions called projection. Actually, we are going to define product topology in terms of projections, in terms of sub-basis. And for sub-basis, that can be expressed in terms of projection. So for that, read this definition. Suppose pi1 is any map from Cartesian product and see from Cartesian product of x and y to x defined by pi of 1 of x y equal to x. See, first of all, always try to look it into replace x and y by r, because that case you know, and then try to generalize it. So you can see that if pi1 is a map from x cross y to x given by this one pi1 of xy, basically we are projecting it to two x axis. If you consider xy as r2, xy as r, let us understand on r first. Let us take x equal to r and y equal to r equal with standard topology. And pi2 we are defining that we are projecting this on y, on the y. We are projecting x Cartesian product x cross y to y by this map. Then pi1 pi2 are called the projection of x cross y onto its first and second factors, or we can say that we are projecting this xy to its first slot. To its first slot here, that is denoted by pi1, and to second slot, that is denoted by pi2. So you can see that we use the word onto because pi1 and pi2 are surjective. Why onto? Because see, to suppose if I replace x by r and y by r, so what will happen that yes, pi1 pi2 are onto y, because if we consider the first one pi1 of x cross y, partition of x cross y, so whatever, let us take any open set of this one, and if we project, let me take this one, if we project on x axis, I mean x axis, then what will happen that we are projecting this to x axis. Then for every x, I mean for every say x here, I always have a pre-image. I always have a pre-image. So you can see that for every x, I always have a pre-image in x cross y. Not to show by this one. That figure is already given next. So here the claim is that all these projection maps are onto in case x and y are non-empty, because if x and y are empty, then their Cartesian product is going to be empty. And second, let us define this map. If U is an open subset of x, if U is an open subset of, then the set pi1 inverse of U is precisely the set U cross v, sorry, U cross y, U Cartesian product of U and y. Why? Actually, see, for inverse, uh, is this notation clear to everyone? What pi1 inverse of U is? ये pi1 इनवर्स क्या डिनोट कर रहा है, कोई बताएगा यहाँ पे आपकी क्लास से? यस, एनीवन? pi1 इनवर्स कैसे निकालते हैं? pi1 इनवर्स, pi1 इनवर्स ऑफ सेट u. क्या हुआ आप लोग, किसी की आवाज नहीं आ रही? ऐसे क्लास में कैसे काम चलेगा? कोई इंटरनल्स? यस, अशफाक, अब्दुल अलीम. पूरी क्लास पिन ड्रॉप साइलेंस हो क्या रहा है? ये ऐसे पढ़ाई थोड़ी ना होती. मैं पढ़ाते चला जा रहा हूँ, आपसे पूछ रहा हूँ, आप लोग कुछ भी जवाब नहीं दे रहे हैं. क्या असाइनमेंट पे पास होने का मतलब ये कि आप कुछ सीखेंगे नहीं? अरे कुछ तो बताओ. ये तो कितनी बार मेट्रिक स्पेसिस में मैं डिस्कस करा चुका हूँ. अच्छा, ये इनवर्स क्या डिनोट कर रहा है यहाँ पे, मुझे बताएगा? ये इनवर्स का नोटेशन क्या डिनोट कर रहा है? ये इनवर्स के लिए क्या कंडीशन होती है? ठीक है, तो इस तरह तो ना आपका डाउट होगा और ना मुझे पढ़ाने की जरूरत है, तब तो सब कुछ खत्म हो जाए. मैंने कब कहा कि आप जो जानते हैं, मैंने तो मैं वो आपसे पूछ रहा हूँ. पूरी क्लास से बताए 45 बच्चों की क्लास है, फिर वही मैं मेथड कर दूं कि मैं आपको पीडीएफ शेयर कर दूं और आपसे ये कह दूं कि अगर आपको डाउट है तो आप पूछें. तो इस तरह तो आपको डाउट होगा नहीं, तो मेरा तो काम पूरा हो गया. अगर आप लोग इस तरह पढ़ना चाहते हैं तो मैं किताब शेयर कर दे रहा हूँ, और अगर जो पॉइंट पे डाउट है मैं उस पर डिस्कशन करा दूँ. अच्छा, इनवर्स ऑफ फंक्शन इन्वर्टिबल कब होता है? कोई बताएगा फंक्शन इन्वर्टिबल कब होता है?
जब फंक्शन बाइजेक्टिव होती है.
जब फंक्शन बाइजेक्टिव है. तो यहाँ ये नोटेशन क्या डिनोट कर रहा है? चलो, आपने बोला यहाँ ये नोटेशन क्या डिनोट कर रहा है. देखो, यहाँ एक बहुत इंपॉर्टेंट डिफरेंस है. जिसको मैं आपको समझाना चाहता हूं। यहां तो ये मैप सिर्फ ऑन टू है, तो यहां इनवर्स की बात कैसे कर लिया?
सर ये प्री इमेज यू के अंदर जो पॉइंट है उस पॉइंट का प्री इमेज नोटेशन कर रहे हैं।
वेरी गुड। बेसिकली दिस इज सेट थ्योरेटिक इनवर्स, नॉट फॉर इन्वर्टिबल फंक्शन। नोटेशन सेम यूज करते हैं। देखो फंक्शन के इन्वर्टिबल होने के लिए इट शुड बी 1 1 ऑन 2, बट फॉर एग्जिस्टेंस ऑफ सेट थ्योरेटिक इनवर्स वी डोंट रिक्वायर 1 1 ऑन 2। ये आप डिफरेंस समझ लो। अक्सर इस नोटेशन सेम यूज करते हैं, दिस डजंट मीन दैट वी आर कंसीडरिंग फंक्शन टू बी इन्वर्टिबल। देखो सपोज f is a mapping from say x to y, suppose कि f कोई मैपिंग है x से y, and here we have some subset t of y, some subset t of y, then f inverse of t, f inverse of t is defined as t is some subset of y, then a collection of all those x belonging to x such that fx, such that f of x belongs to t। यहाँ पे ये सेट थ्योरेटिक इनवर्स है, सेट थ्योरेटिक इनवर्स। इसको मैं वर्ड लिख दे रहा हूं क्योंकि यहाँ पे बहुत से लोग कंफ्यूज होते हैं। सेट थ्योरेटिक इनवर्स, और सेट थ्योरेटिक इनवर्स में नोटेशन हम ये सेम यूज करते हैं, एफ इनवर्स टी। इसका ये मतलब नहीं कि फंक्शन यहाँ पे इनवर्स निकालने के लिए फंक्शन को 1 1 ऑन 2 होना चाहिए। दिस इज कॉल्ड एज सेट थ्योरेटिक इनवर्स। सेट थ्योरेटिक इनवर्स के लिए सिर्फ उन एक्स का कलेक्शन जिसकी इमेज टी में जाए, सिंपली ये डेफिनेशन है। ऐसे सारे एक्स का कलेक्शन, डोमेन के ऐसे सारे एक्स का कलेक्शन जिसका इमेज इस टी के अंदर जाए। सपोज करो कि एक्स से वाई एक मैप है, एक्स से वाई मैप है और वाई का टी सेट है, तो यहाँ के वो सारे एलिमेंट का कलेक्शन जिसका इमेज टी के अंदर जाए, जिसका इमेज टी के अंदर जाए, ऐसे सारे एक्स का कलेक्शन जो होगा वो एफ इनवर्स ऑफ टी कहलाता है। सो दिस इज कॉल्ड सेट थ्योरेटिक इनवर्स। और सेट थ्योरेटिक इनवर्स के एग्जिस्टेंस में वी डोंट रिक्वायर फंक्शन टू बी 1 1 ऑन 2। इसीलिए देखा यहाँ पे सिर्फ ये मैप ऑन टू है, 1 1 नहीं है। अभी मैं शो करता हूँ 1 1 नहीं है, क्योंकि जब प्री इमेज लेंगे, चलो मैं इसको अभी आगे शो करता हूँ, इसको दिखाता हूँ आर क्रॉस आर पे करके। सो रिमेंबर दैट हियर वी विल स्टडी, आई विल टेल यू द डिफरेंस इन सेट थ्योरेटिक इनवर्स एंड फॉर एंड कंडीशन फॉर इन्वर्टिबल ऑफ फंक्शन व्हेन वी रीच द टॉपिक ऑफ कंटिन्यूटी, देयर आई विल डिस्कस। But remember that this is set theoretic inverse and we need to look at all those set theoretic inverse of the set U, set theoretic inverse of the set U. So I need to look at, see pi 1 is a map, pi 1 is a map defined from x cross y, Cartesian product of x cross y to x, and here U is a subset of x, U is a subset of x. So its inverse image is collection of all those ordered pair xy whose image is inside U, whose image lies inside U। ठीक है ना, वो सारे जिनका इमेज U के अंदर हो। So basically what you are saying that suppose if U is any subset of X, if U is any subset of X, then the set pi 1 inverse of U is precisely the set U cross Y, the set U cross Y which is open in X cross Y। अब वो कैसे होगा वो अभी मैप से मैं दिखाता हूँ। Similarly if V is open in Y, if V is open in Y, then recall that pi 2 is a map, pi 2 is a map from x cross y, Cartesian product of x and y to y, to y। So if V is a map here, if V is a any subset here y, then pi 2 inverse of y is going to be members of this type x cross y। अब इसको थोड़ा सा geometrically visualize करते हैं, and later on we will prove that this is also open in x cross y। Now how it is open in x cross y, that let me explain this one from this diagram। So the intersection of these two sets is the set U cross V as indicated in figure 15.2। देखो तो अब देखो एक काम करते हैं। See pi 1 is defined from x cross y to x given by pi 1 of xy equal to x। We are projecting it to first slot। pi 1 यही तो मैप है। तो अब प्रॉब्लम क्या है कि अगर आप यहां पे pi 1 इनवर्स क्या होगा, pi 1 इनवर्स ऑफ u, तो देखो u किसका सबसेट है, u आपको सबसेट यहां पे लेना है, u इज सबसेट ऑफ x। मैं एक काम करता हूं, देखो x क्रॉस y तो ये पूरा प्लेन है, लेकिन ये जो x है वो एक्सिस है, ये x ये एक्सिस है। ओके, सो ऑन दिस एक्सिस टेक एनी ओपन सेट, टेक एनी ओपन सेट ऑफ द टाइप AB। So let me, for the sake of explanation, let us take U is equal to open interval AB, because we know if I equip X as R with the standard topology, then this one is a basis member, and basis members are always open set. So let me take U as open interval AB. U is equal to open interval AB. Now I want to have inverse set theoretic inverse of this set theoretic inverse under this map pi1. So pi1 inverse, basically this pi1 inverse of AB is collection of all those xy from the domain, from this x cross y, such that pi1 of xy belongs to open interval AB. इसकी जो इमेज जाए वो ओपन इंटरवल AB में जाए. Image, अब देखो कैसे. So claim is that if this is your U, then its set theoretic inverse of this U is this whole strip. Why? Because see, if you project, mapping is projection map, means we are projecting this to x-axis. So if we project this whole figure to x-axis, then it will be this. होगा कि नहीं? प्रोजेक्शन का सॉरी यहाँ से परपेंडिकुलर ड्रॉप कर दो इस एक्सिस पे, ऐसे आप परपेंडिकुलर ड्रॉप कर दो हर पॉइंट का, तो देखो यही हो रहा है ना, हो रहा है कि नहीं? pi1 ऑफ xy क्या होगा? अगर मैं कहूं कि ये सेट है आपका, ये सेट है, इसका प्रोजेक्शन एक्स एक्सिस पे क्या होगा? तो चाहे नीचे रखो, यहां से परपेंडिकुलर ड्रॉप करो, तो यही तो इतना पोर्शन आएगा. दिस विल बी द प्रोजेक्शन ऑफ दिस होल प्लेन. इज इट क्लियर टू एवरीवन?
यस सर.
ये बोलते रहे आप लोग ऐसे. My claim is that suppose I have, let me extend it here. So if this is the region, and I want to project it on x-axis, इसका प्रोजेक्शन क्या होगा? इतना ही तो होगा भाई. इस पॉइंट का भी प्रोजेक्शन यही पॉइंट होगा, इसके नीचे लाई करने वाला पॉइंट, इसका भी प्रोजेक्शन सेम होगा. इज इट? प्रोजेक्शन ऑफ दिस वन इज ऑल्सो सेम. So you can see that all these points have pre-image. All these points have pre-image as this one. Here every point lying in this projection has its pre-image, but this is not onto, because this point also has the same image, this point also has the same image, this point also has the same image. So projection maps are onto but not 1-1. Remember, projection maps are onto but not 1-1. Projection maps are onto but not 1-1. ठीक है. तो जो भी आप रेक्टेंगुलर रीजन में जो भी ओपन सेट देखा ना, जैसे ओपन सेट क्या होता है? ओपन रेक्टेंगल्स होते हैं. जैसे मान लो बेसिस एलिमेंट ले लो और देयर यूनियन. सो इफ यू प्रोजेक्ट ऑन एक्स एंड वाई एक्सिस, देन दिस इज गोइंग टू बी दिस वन, दिस पोर्शन, क्योंकि इसके अंदर के जितने पॉइंट आप प्रोजेक्ट करोगे तो यहीं पे तो आगे कट करेगा एक्स एक्सिस पे, तो ये बन गया. सो दिस इज द रीजन व्हाई प्रोजेक्शन मैप्स आर ऑन टू बट नॉट. सिमिलरली इफ आई प्रोजेक्ट दिस रीजन ऑन द वाई एक्सिस, then it will be this one. I mean starting from here to here, it will be this one. तो ये y पे प्रोजेक्शन है इस वाले फिगर का, इस वाले रीजन का y पे प्रोजेक्शन है. So if you project whole xy on x, then basically whole x cross y is this plane, and if I project it on this, then I will get the whole x. ठीक है, whole x. Now here question is that, now then what will be inverse image of this set U? So inverse image of set U, pi1 inverse of open interval AB is collection of all those xy whose image lies in open interval AB. So if I project this, it will be in open interval AB. Even if I project this, again its image lies in open interval AB. If I project this, then its image lies in open interval AB. So I can say that this whole strip is basically inverse set theoretic inverse of this set AB. तो ये पूरी स्ट्रिप हो गई. समझ में आ गया कि नहीं आप लोगों को? कोई डाउट है तो पूछ ले मुझे यहाँ पे भी, आप बोलेंगे तभी तो मैं समझाऊं आगे कुछ. पहला डिफरेंस मैंने बताया कि फॉर एग्जिस्टेंस ऑफ सेट थ्योरेटिक इनवर्स वी डोंट रिक्वायर फंक्शन टू बी 1-1 ऑन 2. मैंने आपको एग्जांपल भी दिया, दिस प्रोजेक्शन मैप इज ऑन 2 बट नॉट 1-1. वो फंक्शन के इन्वर्टिबल होने के लिए कंडीशन है. यहां पे जो है ये सेट है, सेट थ्योरेटिक इनवर्स की मैं बात कर रहा हूं. यू इज अ सेट. सिमिलरली let me consider this one, this set CD, say C and this one is D, and let me call it as open interval V, because on R we have standard topology. I am considering here X and Y as R. So what will be set theoretic inverse of this one? So this whole strip is going to be inverse image. Pi 2 inverse of V will be this whole strip. And collection of all such strip, see if I will is going to form sub basis. Sub basis के लिए क्या क्या condition है? देखो सब बेसिस के लिए कंडीशन है कलेक्शन ऑफ ऑल बेसिस मेंबर्स कलेक्शंस ऑफ ऑल मेंबर्स ऑफ सब बेसिस इज गोइंग टू बी होल space x cross y. So in our case x and y are r, so for r2 r cross r. So if you take union of all such strip, it is going to generate whole r, it is going to generate whole r2, I mean xy plane, it is going to generate whole r2. So this is going to satisfy the definition of sub basis first. So you can see that pi 1 inverse of u is the collection pi 1 inverse of u union pi 2 inverse of v is a sub basis for the product topology on x cross y. Why? Because collection of all strips of this type, all open strips of this type, and collection of all open strips of this type, where strips are parallel to x and y axis, that is going to generate standard, that is going to form the sub basis for the product topology on r cross r. So in the same way here, in general, pi 1 inverse of u, where u is open in x, and pi 2 inverse of v is open in y, their union is going to generate the sub basis, is going to be sub basis for the product topology. Now another condition to check, see there is another condition that if sub basis is given to you, then its finite intersection is going to be basis member for the topology. Basis. Now you can see that, let me take this open strip and this open strip parallel to y. The open strip parallel to y axis as well as open strip parallel to x axis, and you can see that there, see these endpoints are not included because we have open interval AB. A and B are not included. Similarly, C and D are not included. So if you take finite intersection of two parallel such strips parallel to x axis and y axis in R2, then what will happen, that we will get this open rectangular region. And collection of all this open rectangular region, we know that this is the basis for standard topology on R2. So it is also going to satisfy that condition, that whenever that finite intersections of member of sub basis is going to be a member of the basis, यहाँ तो किसी को डाउट तो नहीं है, लेकिन ये याद रखना, ये सिर्फ नोटेशन हम यूज करते हैं पाई 2 इनवर्स या पाई 1 इनवर्स ऑफ सेट. दिस इज नॉट दैट फंक्शन इन्वर्टिबल हो गया, ये नोटेशन हम यूज करते हैं, इससे उससे कंफ्यूज नहीं होंगे. दो चीजें होती है, एक तो फंक्शन का कब इन्वर्टिबल होता है, एंड सेकंड इज सेट थ्योरेटिक इनवर्स. तो सेट थ्योरेटिक इनवर्स के एग्जिस्टेंस के लिए फंक्शन का 1 1 1 2 जरूरी नहीं होता, वरना अगर ऐसा होता तो प्रोजेक्शन मैप का तो कभी आप सेट थ्योरेटिक इनवर्स में इमेज निकाल नहीं सकते. ठीक है, तो ये मैंने बता दिया. अब देखो कितना आसान हो गया प्रोडक्ट टोपोलॉजी को. हाँ, अब इस पॉइंट पे आते हैं जो मैंने यहाँ छोड़ दिया था. Claim is that if U is an open subset of X, then the set pi 1 inverse of U is precisely the set U cross Y, which is open in X cross Y, देखो U open है X में and Y open है. Y पे जो टोपोलॉजी है, see on whatever topology is on Y, phi and Y are a member of always every, phi and full space is always member of every topology. So Y is already there, and we have taken U as open in X. So by definition, their Cartesian product is going to be open in X cross Y. Now Y pi 1 inverse of U is this one, U cross Y, that I have depicted here. That if this is your U, then pi 1 inverse of U, basically pi 1 inverse of U is equal to U cross Y. So you can see that we have this U, actually this strip is represented by U cross Y. We have this U here, and just extend it to Y, along Y, parallel to Y. This is the first slot, so you need to look it on X axis, and this is second slot, so you need to look on Y. So if we extend it along Y, we will get this whole strip. So this is what your U cross B. Open strip. This open strip. ठीक है. Now this proof. तो अगर आपको एक बार ज्योमेट्री समझ में आ गई तो इस प्रूफ में कुछ है नहीं. Now you can see that every open, this is what I have explained just now, this is written here, that finite intersections of basis members, sub basis members is going to be a basis member for the topology. So that is written here, that if script T denotes the product topology on X cross Y, let T denote script T denote the product topology on X cross Y, and T dash script T dash be the topology generated by sub basis. Because every element of this sub basis script S belongs to topology, so do arbitrary union of finite intersection of element of S. So actually, why this will be contained into this one, that this topology generated on X cross Y is going to contain this topology. This is explained here. So on the other hand, every basis element U cross V for the topology script T is a finite intersection of elements of subbasis. So that I have explained through the diagram, that in case of, if you take this rectangular region, this strip pi 1 inverse of U, this whole strip is pi 1 inverse of U, this one is the pi 2 inverse of V, and if we take their finite intersection, then we have this rectangular region, then we have this open rectangular region which is a basis member, So you read this and then again I will come to this proof. तो देखिए अब तक हमने क्या क्या पढ़ा, आज आप इसे पढ़ लें, एक क्लास नेक्स्ट क्लास में मैं एक बार और रिवाइज करा दूंगा। मुझे लगता है हाँ 11:46 हो गया है। आज मैंने आपको एक आइडिया दिया और एक इंपॉर्टेंट पॉइंट ये बताया, क्योंकि बहुत से लोग इसमें कंफ्यूज होते हैं, सेट नोटेशन सेम यूज करते हैं, सेट थ्योरेटिक इनवर्स और इनवर्स फंक्शन के इन्वर्टेबल के लिए, लेकिन दोनों के डेफिनेशन में डिफरेंस है। सेट थ्योरेटिक इनवर्स में कलेक्शन ऑफ ऑल दोज एक्स फ्रॉम द डोमेन सच दैट fx बिलोंग्स टू t। अगर आप सेट थ्योरेटिक इनवर्स एफ इनवर्स ऑफ t निकालना चाहते हो तो सिर्फ ये सिंपल डेफिनेशन, तो इस डेफिनेशन में कहीं भी आपको 1 ऑन 2 की जरूरत नहीं है। आप खुद सोचो कि अगर ऐसा होता तो प्रोजेक्शन मैप्स आर ओनली ऑन टू नॉट 1 तो जब बाइजेक्टिव नहीं तो आप कैसे निकाल लोगे। तो ये एक इंपॉर्टेंट डिफरेंस है जो अक्सर हम पढ़ते तो हैं पर उसे समझने में मिस कर देते हैं। ठीक है, और किसी कोई डाउट है? लेकिन आप लोग क्लास में रिस्पांस बिल्कुल नहीं आ रहा है आपके पूरे बैच का, पता नहीं, मुझे नहीं मालूम आप लोग कितना समझ रहे हैं क्या नहीं, कम से कम इंटरनल्स भी नहीं बोल रहे हैं। लग रहा है आप लोग बिल्कुल क्या वो हैबिचुअल हो गए कि मैं पीडीएफ शेयर कर दूं और आपसे कह दूं कि अगर आपको डाउट है तो डाउट क्लास डिस्कशन करा लेंगे, तो आपके बैच में तो कभी डाउट ही नहीं आएगा, तो फिर तो मुझे पढ़ाने की जरूरत ही नहीं है। क्यों, मैं सही कह रहा हूँ?
नहीं सर।
कुछ तो बोला करें क्लास में, जब आपसे पूछा जाए तो रिस्पॉन्स तो दिया करें। यहाँ मैं मशीन के सामने मुझे ऐसा लग रहा है मैं पता नहीं क्या बोले जा रहा हूँ। ठीक है, ठीक है, रिवाइज करें, जो भी छोटे मोटे डाउट है पूछा करें, तब क्लास इंटरेस्टिंग होती है। जैसे आप लोगों ने वो जो सब स्पेस टोपोलॉजी के मैंने क्वेश्चन डिस्कशन कराए थे, तो उसमें आप लोग रिस्पांस कर रहे थे, तो गलत सही जो कुछ बोलोगे तब तो मैं करेक्शन कराऊंगा ना। अब आप रिस्पांस ही नहीं दोगे तो मैं कहाँ से कराऊंगा। अब आप ये सोच के बैठो कि मैं जब भी बोलूँ सही बोलूँ, तब तो आप नहीं सीखोगे। मैंने बार बार मैं कह रहा हूँ कि आपको जो भी आता है आप बोले, जब पूछा जाए आप बोले, तभी तो मैं करेक्शन कराऊंगा। ठीक है, आपकी अगली क्लास होगी, मैं यहीं पे एंड करता हूँ। नेक्स्ट क्लास में मैं दोबारा ये शुरू करूंगा, थोड़ा सा एक बार और शॉर्ट में रिवाइज करा दूंगा प्रोडक्ट टोपोलॉजी और इस पे कुछ क्वेश्चंस। अभी प्रोडक्ट टोपोलॉजी आप बहुत कुछ पढ़ोगे, कन्वर्जेंस, ये जो आप अभी प्रोडक्ट टोपोलॉजी में जैसे पढ़ते हो ना, वो जो आप एडवांस कैलकुलस में चीजें पढ़ के आए हो, एफ ऑफ एक्स वाई इक्वल टू क्या कहते हैं उसे, से ऑर्डर पेयर एक्स प्लस वाई कॉमा एक्स माइनस वाई दे दिया, तो ये कंटिन्यूअस है कि नहीं, लिमिट एग्जिस्ट करेगी कि नहीं। तो ये सब जो एक्स क्रॉस वाई या ये देते हैं ना, ये सब के सब बेसिकली उस पर प्रोडक्ट टोपोलॉजी होती है। अगर मेट्रिक है तो मेट्रिक से भी प्रोडक्ट टोपोलॉजी जनरेट होगी। तो उसमें हम क्या करते हैं, स्लॉट वाइज उनकी कंटिन्यूटी वगैरह चेक कर लेते हैं। तो इसमें देखेंगे कि मेट्रिक में तो ठीक है, एफ एक्स वाई अंडर ये कार्टेशियन प्रोडक्ट ऑफ मेट्रिक, सॉरी मेट्रिक कह रहा हूँ, कार्टेशियन प्रोडक्ट सपोज, चलो ठीक है, अब नेक्स्ट क्लास में बताऊंगा। वहां पे आप देखो कि टोपोलॉजी में एक्सेप्शन है, मींस अगर सारे स्लॉट फंक्शन कंटिन्यूअस तो जरूरी नहीं फंक्शन कंटिन्यूअस है, लेकिन फंक्शन कंटिन्यूअस तो सारे स्लॉट फंक्शन कंटिन्यूअस है। और एक्सेप्शंस वगैरह मिलेंगे बॉक्स टोपोलॉजी और इन सब में, यूनिफॉर्म टोपोलॉजी वगैरह में, लेकिन प्रोडक्ट टोपोलॉजी में ट्रू है ये। ठीक है, मैं बंद करता हूँ, फिर नेक्स्ट क्लास में डिस्कस करेंगे, पढ़ के आएंगे, मैं अगली क्लास में पूछूंगा आपसे।